So today I thought I would make a video that's a little bit different and talk about how to utilize AI models for scientific experiments, and particularly my philosophy and approach regarding these things. And highlighting that up front, this is my philosophy and my approach. Many different ways to do things. There's many different right or wrong ways to do things, and there's many different right ways to do things. And so just highlighting this is my way to do it. And so the way that I look at these things up front is that I think that it is good that a lot of people are getting into and doing more and more scientific experiments with AI, right? That's the benefit of AI overall. Like outside of any sort of marketing pitches or what businesses want it to be, AI to me is a knowledge bomb. It's a knowledge dissemination, right? And the knowledge is in your hands as to how exactly you want to utilize that. And that's what I want to get into directly with this video. The kind of bad, if there's, and I don't think it's a bad thing, if there's any sort of downside with that approach, it's that people don't necessarily understand how these models work for this type of experimentation to get into it up front, and that can be frustrating for people. And so I think that a lot of people, they kind of treat it like a Minecraft game is how I approach it in my head, and I think about it in my head, where they think, let's say that I have a problem, and I'm just going to pick Schrodinger's box, right? Because that's the very first thing that popped into my head. And then so let's say that Schrodinger's box exists somewhere in the universe. And then so we just prompt an AI model with this information. And then we expect kind of like Minecraft Claude to go out and start mining all of the like information around quantum mechanics, right? And then eventually Minecraft Claude is just going to hit Schrodinger's box, and then, oh, here's the answer that you want, sir. This is what you were looking for, but that's not like how these models approach, and how you have to approach experimenting with these models. Science is, always has been, and always will be about experimentation, right? About setting up experiments, making observations, and then adjusting your hypotheses based off of those observations. Nothing changes with that process. With AI, AI just makes it a whole heck of a lot easier. In my mind up front, like, and I'll say it a million times to anyone, Einstein is now and forever the GOAT. Like, no one will ever touch Einstein, and no one can ever touch Einstein from here forward, because he did all of these things without compute. Like what we're going through now and what we're going to go through in some of these videos, like Einstein did this without computers, without AI. And that's the major, but like we are, to me, are standing on the shoulders of giants with this technology. Like I am amazed at what you can do with this, and that we are going to go through this within this video. And then so diving deeper into this, and making this into an actual experiment, and taking this into real world terms. Like, what does this actually look like, right? What does this approach do? Like, how do you do this? Okay, it's simple to say you need to experiment with the model as opposed to just going through. And then so to me, like, the big thing, and this reality within that, is that you yourself need some base knowledge in order to conduct these experiments, right? You need base knowledge, and if it's physics, chemistry, whatever area, mathematics that you want it to be, you need to understand, at least on some base level, what you're doing, right? What the AI is doing, enough to ask questions to set up the experiment. It's great, like, because it would often be a challenge within experiments, because perhaps you run into a situation where you need to know, like, advanced geometry, or you need to know linear algebra, or you need to know calculus, or you need to know some logical theorem, and you don't have that specific knowledge to move forward with your experimentation. That's where you utilize the AI models, right? You don't just say, hey, go Minecraft out the full solution. Say, hey, like, I need to know like how like Planck emergence works, and tell me about that concept, because I'm running into problems with it. And you go from there, right? And kind of that kind of logic. And so diving into that and utilizing that into real world terms, let's utilize an example that I have recently built out. This is my most recent concept that I've built, so that's why I utilize this example. And this is a self-sustaining chemistry neural network. And this is the result of a lot of experimentation, right? And then I show these things and I showcase oftentimes the end result of these things. And I think that like maybe perhaps like a lot of people say like, oh, and they see like this is the end result. It's pretty easy, right? It's just a bunch of code. But once you understand the code and dive into it, then that's it, right? But like this isn't it, right? So stepping back, like peeling back one layer from here, the first thing that I had to do before creating this model is I had to create AI chemistry. and then so essentially I created this, right? Which you have atoms, bonds, molecules, reactions, and then environments, energy and entropy. I'm essentially teaching the AI model everything about chemistry, these broad concepts of chemistry, and then telling it, utilize these broad steps of chemistry, and then this is exactly how I want to utilize them within your framework, within your textual framework, right? So atom is going to be a capital A. This is exactly how I want you to utilize atoms within code. This is exactly how I want you to utilize bonds within code. You can add atoms plus bonds. So you can add A plus B, and you can get reactions. If you add A plus B, this is the specific reaction and the specific products that you get. And then knowing that information, we can judge and then predict other reactions and other outcomes for C, D, and E based off of the reactions of A and B. But I'm literally feeding and constructing all of this information for the model, right? So step one is knowing and being able to construct this information and then put it in. And then step two, or at this point, honestly, step 50 in the process is the end result here that we're looking at. And then with this end result, it's the culmination of all of the knowledge, right? So like essentially this is a culmination of chemistry, linear algebra, trigonometry, and physics, and all of that combined, right? And then my knowledge is not as strong, like it's not uniform across the board, right? Out of all of those subjects, my knowledge would be highest in physics, second would be trigonometry, third would be probably linear algebra in this instance, and then fourth would be chemistry. Like chemistry is my weakest subject within this, right? And then so I'm heavily reliant on the AI model for the chemistry interactions within this. And then because I need to rely on the AI model so much for that chemistry knowledge, that's why I'm feeding the AI model AI chemistry, right? I had to go through and do all of these exercises to put my knowledge gap into the best box that I could. And I had to do that as step one of my experimentation, right? Up front, know what my knowledge gaps are within it, and then frame it. Like I'm not feeding the model AI physics because I don't need to. Like if the model comes out with incorrect physics within this, I'll just correct the model. Yeah, I'll just look at the code and say, hey, you're doing this wrong, bro. Let's fix that. But I can't do those same things if it's doing the chemistry wrong. If it does chemistry wrong, I don't know. So I need to here's your baseline, here's your instructions, here's the instructions that I have set up and I know now are 100% good. So follow these guidelines. If you follow these guidelines, I know it's if we have errors, there's something wrong, and we can go from there. And it's not something that you did wrong, right? I know that, and then so I can do that and then go through, and that's exactly how we build this out, right? And then the same thing with physics. Like I think perhaps a lot of people might think that my physics knowledge is maybe this guy in the last year he just buckled down and learned physics, right? I've been obsessed with physics since I was 6 years old. I've always thought that flat out, I'll put this out here. I've always thought for my entire life, I've thought that Stephen Hawking's wrong. I can now, at this point, like I can prove to you at this point that that Hawking radiation is BS. Like if you want to, if you're out there and you're listening to this and like, hey, you want to go the scientific route, flat out, I can prove to you flat out scientifically, mathematically, through a lot of different formulations and a lot of different formulas. Stephen Hawking was wrong. Sorry, he's gonna get written out of the history books. He shouldn't be in there in the first place. Like that's how I've thought my whole life. But so you can see, like it's not just like again Minecrafting, Minecraft GPT, Minecraft Claude, Minecraft Gemini, right? Like I'm utilizing existing knowledge and building off of that, and that's the key element. And then for at least our lifetimes and our generations, that key element's not going to go away. And I think that's beautiful, right? Like, what does it mean to be human? It means to collect knowledge, to live, and to grow, and to grow together, right? And then so that's just all part of that, and this all part of knowledge communication and knowledge dissemination. And I think that's why we're here. And if you like this type of content, please like and subscribe. Thank you very much.